Variations in the first ionization energy down a group. Ionization energy is the amount of energy required to remove 1 mole of electron from 1 mole of gaseous atom to produce 1 mole of unit positive ion. If we look at this example, this A here represents a neutral gaseous atom, meaning equal number of protons and electrons. Since the positively charged nucleus attracts the negatively charged electrons, it requires energy to remove 1 mole of electron from the gaseous atom. This is what we call ionization energy. After the removal of 1 mole of electron, it is no longer a neutral gaseous atom, but it forms an unit positive ion. The gaseous atom gains energy in kilojoules to remove 1 mole of electron. So the unit for ionization energy is kilojoules per mole. And that's the basic for ionization energy. In this video, we're going to focus on the first ionization energy down a group. So I'll be using the group 1 elements from the periodic table to demonstrate my lesson today. Our first element in group 1 is hydrogen. Hydrogen in the gaseous state needs about 1312 kilojoules per mole of energy to remove 1 mole of electron, whereby lithium requires 519 kilojoules per mole of energy, followed by sodium requiring 494 kilojoules per mole, and potassium needs 418 kilojoules per mole of energy. As you can see, there is a clear trend, which is the first ionization energy is decreasing down the group. Well, why? This is due to the factors that affect the ionization energy. Ionization energy is influenced by 3 factors. First, the distance of the valence electron from the nucleus. Second, the number of protons in nucleus. Third, the shielding effect of electrons in the inner shells. So let's have a look how does these factors influence the trend to decrease down the group. Firstly, hydrogen. Hydrogen has 1 proton in its nucleus and 1 electron in its shell. The electronic configuration will be 1s1. So this negatively charged electron will be attracted by the nuclear charge. In order to remove this 1 electron, it requires 1312 kilojoules per mole. Next, for lithium, the proton number is 3 and electronic configuration is 1s2 2s1. The number of shells for lithium is more compared to hydrogen. When the number of shells increases, the number of inner electrons increases as well. This eventually increases the shielding effect. Shielding effect is a repulsion between the inner electrons. As a result, the atomic radius also increases. Hence, the distance between valence electron and nucleus increases, causing the attraction between them to become weak. So, it is easy to remove that 1 valence electron from lithium compared to hydrogen and requires lesser energy. This is why the first ionization energy for lithium is lower compared to that of in hydrogen. This same case follows the other elements as it goes down the group 1. So let's recap all the points again. As we go down the group, the number of shells increases as the proton number increases. This results in the increase of inner electrons and shielding effect. Thus, the atomic radius increases and the distance between outer electron and nucleus increases. This also weakens the attraction of nucleus towards the valence electron as it goes down the group. So, the removal of 1 mole of electron is a piece of cake. As a result, the first ionization energy decreases down the group.